Naam, tunaendelea. Hii ni lecture number 7. Na tunamalizia point ya mwisho ya kuhusu advantages of using high transmission line voltage. Point number 3 ilikuwa ni kwamba na decrease the voltage drop. Sawa. So let's consider a simple transmission line. Suppose this is a generating station, and this is a sending end. Transmission line has a resistance and inductance. Okay, this is a load. When current is flowing through the transmission line, this is the resistance, this is a reactance, XL. Okay, when current is flowing through the transmission line, voltage drop is given by current that flow through that transmission line times the impedance, the series impedance of that transmission line, and this impedance is given by R squared plus X squared. Okay. By hiyo voltage drop, let's say this is VD equals to I times R squared plus X L squared under root. Okay. By hiyo we know that I is given by power over under root 3 VL cos pi. Substitute hapo tutapata voltage drop V3 equal to P over under root 3 VL cos pi times impedance ambayo ni R squared plus X squared under root. Okay? Kwa hiyo if P is constant, load power factor ni constant, ndio. Kwa na impedance Z is constant. Kwa tunaona voltage drop V3 equal inverse proportional na transmission line voltage with the L. Kwa hiyo the more you increase the transmission line voltage, the more the voltage drop decreases. Okay? Kwa hiyo inafanya inapelekea kwa transmission line kuwa na better voltage regulation. Okay? Sasa tuendelee zaidi kuona kwamba tumeona kwamba advantage za tufanye quick recap hapa. Advantage of high transmission voltage. Tunaona ya kwanza ni kwamba it reduces the volume of conductor material. Okay, ambapo tunaona kwamba volume of conductor material iko inverse proportional VL square. Ndio. Ya pili tunaona kwamba it increases the transmission line efficiency. Ambapo tunaona efficiency is given by 1 minus under root 3 J times L over VL cos pi. Okay, na baadaye tukaona kwamba it decreases the line voltage drop. Sawa, ambapo tukaona voltage drop iko inverse proportion to VL. Okay, sasa kuna limitation pia ya kutumia high transmission voltage. Kuna limitations of high transmission voltage. Okay, sasa kwa nini limitation? Kama ushawahi kuchunguza transmission line voltage, ambazo zinatumika kulingana na tufate British convention. Sawa, ni huwa ni kuanzia 66 kV, 11 kV, 33 kilovolts, 66 kilovolts, 132 kilovolt, 220 kilovolt, 400 kilovolt, 765 kilovolt na current, na nchi nyingi zilizoendelea sasa hivi zinatumia 765, ila kuna tafiti zinaendelea kutumia 1000 kilovolt. Unaona? Sawa. Na sasa kwa nini tusijiulize why let's say not, why not kwa nini tusitumie labda 5000 kilovolt au 10000 10,000 kilovolt as transmission line voltage. Sawa. Kwa nini tusitumie hizo hapa? Kwa sababu kuna some limitation pia ya kutumia high transmission voltage. Limitation ya kwanza, ukitumia high transmission line voltage, first limitation, kwamba the cost of insulator increases. The cost of insulating the cost of insulating conductor increases. Kwa maana ya kwamba the cost, tusema andika kwanza hii point, the cost of insulating conductor increases. Sawa. Kutumia high transmission line voltage. Sawa. The cost of insulating the conductor increases. Au tunaweza kusema the cost of providing insulation to the transmission line conductor increases. Tunaweza kusema kwamba the cost of providing insulation to the transmission line conductors increases. Sawa. Sasa ni insulation zipi conductor zinatakiwa ziwe insulated in two ways. Sawa. Then tunasema kwamba kuna namna mbili ya ku-insulate the conductor. Insulation ya kwanza ni provide insulation between conductors themselves. Sawa. Na nia pili ni provide insulation between conductors and the ground. Sawa, insulate the conductor, provide insulation between conductors na ground. Kwa maana ya kwamba tunajua kwamba transmission line inaweza kuwa ni overhead transmission line au ni underground transmission line. Nasema transmission line inaweza kuwa ni overhead transmission line au ikawa ni underground. Okay? Transmission line. Sasa hii overhead ni conductors zinakuwa zina hang, okay? Zina hang above the ground. Okay? Conductors zinakuwa zina hang above the ground. Na underground transmission line nasema conductors are buried into the ground. Conductors zinachimbiwa chini above the ground by means of underground cable. Sawa, kuna underground cable. Kwa hiyo tukiangalia katika conductor above the tukiangalia kwa kesi ya overhead transmission line inakuwa ni this is the transmission line tower, okay? For simplicity, transmission line tower. Okay? Conductors kuna insulators na consider case ya three phase conductor, kuna insulators. More conductor zinapita. Conductors hang. So let's say this is a level ground. Okay? Okay? Kwa tunaona hii ni insulator. This insulator provide insulation between line conductor and this closum. Okay? Tunasema closum tunasema ni ground. Kwa hiyo this insulator prevent the leakage of current from the line conductor directly to the ground. Kwa hiyo na provide insulation between conductor and ground. Okay? The same applies to these insulators and this insulator. Kwa hiyo inaitwa ni ground insulation. Sawa. Kwa kuna insulation between conductor. In case of overhead, insulation between the conductor ni air between the conductor. Okay? Ambao amount of insulation inakuwa inaweza ikawa added or decreases depending on the spacing between the conductor. Okay? Kwa hiyo ukitumia high transmission line voltage kwa sababu air is just available for free. Ni in case tu ya kwa just ile spacing between the conductor ili kuzuia ile breakdown of air. Okay? Tunajua kwamba hapa kuna electric field. Electric field ikiwa very strong kushinda dielectric strength of air ina act kama conductor. Kwa hiyo to adjust the insulation between the line conductor, unatakiwa adjust only the spacing between the conductor. Hakuna gharama kubwa. Gharama kubwa tu itakufanya uwe na close arm depth na tower ambayo ina strength kubwa. Kwa hiyo cost implication yake si kubwa kiasi hicho, lakini kuna insulation between the line conductor and the ground. Okay, the more you increase the amount of the high transmission voltage, you have to also to increase the amount of insulation required to insulate between conductor and ground. Kwa hiyo the cost of insulator also increases. This insulators unatakiwa ununue sasa, unatakiwa uwe na insulator, for example labda this line is 220 kilowatts, okay? Kwa unatakiwa uwe na insulators ambazo zinaweza zikawithstand around 220 kilowatt. Kwa hiyo tunaona kwamba the more you increase the transmission line voltage, also the cost of insulators, these insulators, the insulator between the line conductor and the ground also increases, kwa sababu unatakiwa ununue hizi insulator ambazo ni insulator material ambazo zinatumika hapa ni glass. Glass, you have to buy glass insulators for glass. You have to buy wengine wanasema natumia porcelain, natumia porcelain, sijui kama nimeandika vizuri, yani porcelain insulators. Kwa hiyo this glass material and porcelain insulators are not available for free. Sio kama air just available for free, na just to spacing between the conductor, then mambo yanakwenda. Lakini increase transmission line voltage, ile ground insulation between line conductor and ground, ambapo tunatumia glass au porcelain, lazima this material haziwi available for free, you have to buy. Sasa kwa hiyo unaona kwamba the cost of insulating the conductor also increase. Kwa kesi ya underground cable simply ni cylindrical shape, simple cable, okay, ambayo inakuwa na conductors, okay, ambayo inakuwa na conductor to consider kwa kesi ya hii phase, okay. Kwa kesi ya underground cable, we can increase transmission line voltage. For example, this conductor, this cable is for let's say 33 kV, imekuwa designed to operate katika 33 kV. If you increase the transmission line voltage maybe to let's say 132 kilovolt, ina maana you have to buy another cable ambayo itaweza kuwithstand 132 kilovolts. Kwa hiyo underground cables cost yake, tunasema the cost of underground cable depends also on the operating voltage. Sawa. Kwa hiyo ukichukua 33 kV cable and 132 kV cable of the same cross section area, okay, kuna jikuta 132 cable is more costful than this 33 kV cable. Kwa hiyo the more you increase the transmission line voltage in case of underground transmission line, pia na the cost of cable inaongezeka. Kwa nini cost of cable inaongezeka? Cost ya cable inaongezeka kwa sababu you need more insulation to that cable in order to be able to work safely under that operating voltage. Sawa. Kwa hiyo unatakiwa wale manufacturers wanatakiwa provide much insulation in order to withstand that operating voltage. Okay? Kwa hiyo ndo point ya kwanza kuhusu limitation of high transmission voltage, jambo tumeona kwamba ni the cost of insulating conductor ina increase. Sawa. Point ya pili ni kwamba the cost of transformers, switch gears and other terminal apparatus increase. So, with the cost of transformer, okay, the more you increase the higher transmission line voltage, the cost of transformer, the cost of switch gears increase. For example, ukiwa na transformer, let's say 1 MVA, sawa, transformer, sawa, tuseme ni ina operate at 33 to 132 kilowatt. na transformer ile ile ya 1 MVA lakini ina operate from 33 to 220 kV. Sawa. Unakuta transformer hii ambayo ina operate from 33 to 122 is cheap compared to 33 to 220 inakuwa costful. Okay? Inakuwa costful. Umeona? Kwa hiyo increase ukitumia high transmission voltage unajua kwamba also the cost of transformer increase. Pia also switch gears na kwa mfano circuit breaker. Okay, circuit breaker kwa ajili ya kufanya kazi kwenye 33 kV na circuit breaker kufanya kazi kwenye 66 kV. Hizi circuit breaker gharama zake ni tofauti. Hii ya 33 kV inakuwa na gharama ndogo kulinganisha na hii ya 66 kV. Kwa hiyo the more the operating voltage, the more the cost of circuit breaker. Okay, the same applies to other terminal parallels kama lightning arresters, CTs, PTs na kadhalika. Umeona? Kwa hiyo sasa mpaka sasa tumeweza kujifunza vitu vingi kuhusu principle of electric power transmission, na katika lecture inayofuata tutaangalia zaidi kuhusu namna mbalimbali sasa za kutransmit electric power. Tunaweza tukatumia overhead au underground, tunaweza tukatumia AC au DC. Sasa tutakuwa tunaenda tunakompare, je, what about if nikitumia DC, what about the cost of material? Je, tunakompare ipi itatumia material kiasi kikubwa, kwamba the volume of conductor will be used large compared to labda kutumia AC. Kwa hiyo na kusiendelee kwa pamoja, uweze kushare, kusubscribe ili tuweze kuwa pamoja katika lecture series hii. Asante.